Welcome everyone to our class on operation management. We are discussing in the last class the different types of layout, and quickly we'll do revision of these different types of layout. The first we have spoken about process layout. So process layout, this is important. These five types of layout is important for your exam purpose. So when we talk about process layout, the other name of process layout is functional layout or job shop layout. So what does it mean? It basically means that here the machines doing similar kinds of works are placed together. So in the case of process layout, we bring out all the machines which do similar types of work. They are grouping together. So it involves grouping together similar machines in one department. For example, the machine performing drilling operations are installed in drilling department. The machine performing turning operations are grouped in turning department and so on. So here it is used when the product whatever we are engaging, okay, they are custom made or small in quantity. So process layout we basically use for those kinds of products which are custom made or they might be small in quantity. Example of the industry can be machine shop making different machine parts based on the customer orders. Okay, so it cannot be worked for mass marketing or mass production purpose. It can be only used for customized purpose. Okay, this is process layout where you are bringing all the machines of similar nature in one department. Here you can see with the example. Okay, so advantage of using process layout is that it is flexible for different product equipment, easily adjusted for new job. Disadvantage can be that the material moves long distance between departments and scheduling and supervision can be sometimes harder. Okay, so this is about process layout. This cannot be used for mass production. It can be only used for some kind of customized production. So there the process layout probably looks better. Then we talked about product layout. When we talk about product layout, the other name of product layout is live processing layout or flow line layout. And what does it mean? Here the machines are arranged in same order as the steps in the production. So in the product layout, we don't bring grouping of machines, similar machines together as we did in the process layout. But in the product layout, it's a simple layout model where depending on the operation, like suppose you need to do first loading, then drilling, and then grinding. So you put the machines of loading first, followed by drilling, followed by grinding. Okay, so depending upon the processing, that way we arrange the machine. That is what we do in the case of product layout. Okay, and like example, in an assembly line, the product move from one machine to the next. It is used when the same product is made in the large quantities. For mass production, you can use product layout. Example industry can be automobile, bottling plant, electronics assembly. Advantage of using can be high production rate, low material handling cost, simple supervision. While the disadvantage of using it would be not flexible for product changes. Okay, if one machine stop, then the whole line will stop. That is a disadvantage of using uh, product layout. So we have spoken about process layout, then we have spoken about process layout, then we have spoken about product layout. I hope you got the difference between both of them. Okay. Then talking about fixed position layout. So when we talk about fixed position layout, so in the case of the fixed position layout, it is used when the product stays in one place and workers, machines, and material come to it. Okay, it is used when the product is very large or difficult to move. Simple by the name we are understanding. Like here you can see an example, the ship assembly plant. Okay, so advantage it could be less movement of the main product suitable for big projects. Disadvantage that it can require a good planning and space can get crowded. So in the case of fixed position layout, the product position does not change, but the worker, machines, and materials keep changing depending upon the requirement. So it's very easy. I think you would have understood. Now we have spoken about process layout, we have spoken about product layout, and now we have spoken about fixed position layout. I think all these things are very easy. You would have easily understood them. Okay. Okay. Then, if I talk about hybrid layout or mixed layout, what does it mean? So here in the hybrid layout, you can see what we do in hybrid layout. As the word itself is telling you, it is a mix of two or more of the above layout to suit the complex production. So in the case of combination layout or mixed layout, whatever the layout model we have discussed, either process layout or product layout or fixed position layout, we mix some models or some layout depending upon our objective, and that way if we are using the setup that is called as combination layout. Okay, so it is used when the product and operations are varied and not easily handled by one layout type. Okay, example can be factory may have a product layout for assembly and the process layout for machinery part. Okay, so a factory can have different kinds of layout. Maybe they're using product layout for assembly while they are using process layout for machinery. So that can be the example. Advantage, it use the best features of different layout. It is flexible and efficient. Disadvantage can be more complex to design and it is difficult to manage. So I hope you understood this. Then we have another kind of layout which we call as cellular manufacturing layout or group technology layout. It is used when there are different products but some need a similar processing. Like here, the machines are grouped into small cells and each cells make a family of similar parts. Advantages can be it reduces material movement, better quality control, it combines the flexibility of job shop and efficiency of product layout. Disadvantage can be initial setup and grouping require analysis and time. So basically, we have spoken about these different types of layout. Okay, so I hope you all have understood these types of layout. Okay, in the case of process layout, we bring similar machines together. In the case of product layout, machines are arranged in the production sequence. In the case of fixed position layout, products stay in one place while the machines, material, labor, everyone moves depending upon the work requirement. In the case of cellular layout, machines grouped by parts families. While in the case of combination layout, we use mix of layouts. So any doubt, any question you all have?
No, sir.
Okay. So going further, like we have discussed these different 1 minute, we discussed about uh, the different types of layout. We have discussed about the importance of layout. Okay, we have discussed about the importance of layout. These are the layouts importance we have discussed, like avoidance of bottleneck. I think you all understand this term bottleneck. So bottleneck refers to any place in the production process where the material tends to pile up or produced as a rate at the speed lesser than the subsequent. So this is about bottleneck creates problem in your layout process, and so wherever if we can identify bottleneck, it's important to work on them. So these are the basic importance of layout we have discussed in the last class. And then this was the numerical which we have discussed, and I think we need more attention of to work on this numerical. Like here in this numerical it is given about this layout is given, like we had discussed about different types of layout, either it's a process layout or product layout or fixed position layout, cellular layout, combination layout. So here also this is one layout is given. Okay, you can see this layout. Okay, and the here what is written in illustration 11, that the manager of the department is intending to interchange the department C and F in the present layout. So you can see this is the layout structure where the what the manager is thinking. Manager is thinking to interchange the position of C and F. Okay, and the handling frequency between the department is given to us. Okay, this is the handling frequency. This is given to us. Okay, as per the numerical, this handling frequency is given to us. Okay, and all the department are of same size and configuration. Okay, the material handling cost per unit length travel between department is same also. Everything is assumed as constant. That the machine size, sorry, department size is same. The material handling cost from one department to other department, if it travel, that is also same. So the question is that what will be the effect of interchange of department C and F in this layout? So the question is that if we try to interchange the department C and F, what would be the effect? Is this changing department is idle, or we should not change the department? That is your question. I hope you have understood the question. Fine now. So here, like if you see in this numerical, so this is a layout given to us ACE BDF. Okay, everyone. So based on this, can I assign row number and column number to all these layout? Okay, so A would be row 1, column 1. C would be row 1, column 2. E would be row 1, column 3. B would be row 2, column 1. Okay, D would be row 2, column 2. And F would be row 2, column 3. Any doubt?
No, sir.
So, based upon their layout, and we can assign a row number and column number to them, and then we can calculate the distance, like from A to B. The distance would be 1. How the distance would be 1 from A to B, you can see. So, if I ask you from A to B, so what you do from, if I'm asking you from A to B, we'll calculate the distance. Distance would be what? You can do first row wise. So you can just use row wise. So row wise, like A minus B or B minus A, you do. Okay, just calculate the difference, and then just add the difference. Then you did row wise. Now do column wise. This minus this. Okay, and then you add it. So you will get the value 1. So A to B, if you do row wise, row 1 minus row 2, 2 minus 1 is 1, and then 1 minus 1 is 0. So 2 minus 1 is 1, 1 plus 0, A to B, it would be 1. You understood the distance?
Yes, sir.
Then we can do for A to C. Okay, A to C, if I ask you what is the distance between A to C, how will I calculate? Same wise, we just need to subtract A to C row wise. If I do 1 minus 1, 0, plus A to C 2 minus 1. 2 minus 1 is 1. Okay. Similarly, I can do A to D. A to D, if I do A to D, 1 minus 2, 1 minus 2 is 1. Ignore the sign. And here 1 minus 2. 1 minus 2, 1 minus 2, 1 plus 1, 2. Similarly, we can find A to E. What would be A to E distance? A to E distance would be what?
2.
2. Okay. A to F.
3,
3. Then B2C,
2,
2. B2D,
1,
1. B2E,
3,
3. B2F,
2,
C2D,
1,
C2D is 1. C2E,
1,
1. C2F,
2,
D2E,
2,
D2F, this is 1.
1,
E2F,
1,
1, 1, 1 only, na? 3 minus 3 is 0, and 2 minus 1 is 1. So we got the distance, and then this is given to us. The handling frequency is given to us. Okay, A to B is 0, then A to C is 90, then A to D is 160, A to E is 50, A to F is 0, then A to B is 0, so B to A is also 0, then B to C is 70, B to D is 0, B to E is 150, B to F is 130, then C to D is 20, C to E is 0, C to F is 0. So what all possibility will get here? A to B. So A to B is 0, so there's no point of taking A to B. Then we have A to C, then we have A to D. Okay, then we have A to E. Okay, then we A to F is 0, don't take it. Then B to C, we can take B to C. Okay, then B to D. B to D is 0, don't take it. B to E, B to E. Then we can take B to F. Then C to D. Then we can take C to D. Then C to E is 0, C to F is 0. Leave it. We can write down their frequencies. These are their frequencies. We can write down their frequencies. And then we have the distance. We have already calculated the distance here. Okay, so we have the distance. So this is the frequency what is given in the problem. Then this is the distance which we have calculated now. So we'll compute the cost. So this is the cost formula. Cost formula is the frequency into distance. For each pair, we'll calculate their cost, and the cost would be like for A to C, A to D, A to E. Like we'll calculate the cost. So the cost what we are getting is 1230 with the existing setup. Okay, everyone, this part is clear, right?
yes, sir.
Then what we did, then we'll talk about the new layout. So this is the new layout what we have. So once we have this new layout, so with this new layout, again you can assign row number, column number, then you can calculate the distance, and then you can calculate the total handling cost by multiplying the distance with the frequency what is given in the problem. And then we got the total cost is 1410. So earlier the total cost was around 1230. Earlier the total cost was 1230, and now your cost is 1410. So with this you can easily understand that when you swap the department C and F, then your total handling cost has increased by 180 unit. So interchanging of the layout does not make any sense. So it won't be idle if we interchange the department. Any doubt?
No, sir.
Fine. So this was the illustration one. Going further, this is illustration two. So illustration two, sorry, 12. So here it is given as a defense contractor is evaluating is machine shop current process layout. So layout again is given. So we can assign row number, column number. E would be 1 1, B would be 1 2, F would be 1 3, A would be 2 1, C would be 2 2, and D would be 2 3. Correct, na? So here the layout is given. Okay, this is the current layout, and then this is the what you say the here requires the current figure below the current layout and trip matrix, and the table gives us the trip matrix for the facility, for maybe some costing score or something is given here. So load distance score something is given. Fine. And here what they're asking you, uh, can you improve this layout? Also, it is given the problem that the department E and F will remain in their fixed position. You cannot interchange the position of department E and F. So you have A, you have B, you have C, you have D. You can interchange their position. Okay. Okay. And then you see which is the like can you improve this or not. So that is the thing. So this is the layout what is given to us. So EBF where ACD where you cannot interchange the position of E and F. So what I can do, I can make E, then here I cannot interchange E and F. Okay, rest other things I can interchange. So, so if I copy this, so how many possibility we can create? So how many possibility we can create? So if A and B, if I interchange their position, A, then here B, A and B I interchange, then C and D remain the same. Okay, A and B I interchange. Here, keep B and A same place. Okay, now I have interchanged the position of C and D. Okay, so now I have interchanged the position of C and D. Okay, then first I have interchanged the position of A and B. Then I have interchanged the position of C and D. Okay, now what I can do? I can interchange the position of A and B. At the same time, I can interchange the position of C and D. Okay. Any other possibility is there? Any other possibility? I think these three possibilities there, right? So we have three possibilities. We cannot change the position of E and F. So I interchange the position of A and B. Then I have interchanged the position of C and D. And then I can interchange the position of all of them, A, B, C, D. Or what I can do, I can bring D here. I can bring D here. I can bring D here. C position, leave it here, and A position, leave it here, and then I'll bring B here. This is the one possibility. This can be the one possibility. Here, what I did, I interchange the position of B and D. Okay, I interchange the position of B and D. This can be one possibility. I interchange the position of B and D. Okay, then what can be the other possibility? I interchange the position of B and D.
A in the place of D.
Here, here A. Let me interchange the position of C and A, and then we'll change the position of A and D. So first I have interchanged the position of A and B. Then I interchange the position of C and D. Okay, so we A, B, C, D, we have four places. So like this, then we have interchanged the position of all of them. Like this, there would be many more cases like this. Then I have interchanged the position of A and the B and D. B and D, I have interchanged the position. Okay, then I have interchanged the position of A and C. Sorry, A and D, I have interchanged the position. No, no, A and D, I have interchanged the position. A, here D will come. Here C will be there. Here A will come. So I think there would be much more possibilities. 1 minute. 1 minute. So like if I go with the rule of permutation, so four objects are there. You can interchange their position. Then we can create, I think, 24 ways and all. So we cannot write all the 24 ways and all. So because four objects are there, A, B, C, D. So we can keep interchanging their place. So four-person can sit in four places in 24 ways. So like this, 4 factorial you studied in permutation combination. So like this, we can create 24 possibilities. So we cannot work on all the 24 possibilities here. So, but more or less, what we need to do, we understand how to uh, f- do this. This is called Manhattan distance formula. We know how to do this. Okay, whatever would be our grid layout and all. Based on that, we'll assign row number and column number to different departments and all, and then we'll calculate the distance between the department. Okay, we'll calculate the distance between the department where we'll apply this formula of distance. Okay, this is the formula of distance what we'll apply. Whatever would be our layout, we'll apply this formula of the distance. And once we get the distance, then as per the metrics, they have given us the flow data. Okay, they've given us the flow data, flow cost and all, from one department to the other department. So whichever department data is given, like A to B is given, A to B, A to C, then A to D is not given. So I'll not write. So A to B is 8, and I know the distance between A to B. Then I know A to C is 3, and I know the distance between A to C. Then A to E is 9. I know the distance. A to F is 5. Like this. So whichever data is given, I'll just write down those pair. Okay, their distance already we have calculated. The flow is given in the numerical. In your exam, in your numerical, the flow will be given to you. So just multiply the flow with distance, you'll get the cost, and we'll consider that setup which has the minimal cost. Okay, so we here creating 24 possibilities would be very difficult. Okay, but just for your understanding, this is the way how will you do. Clear, everyone?
Yes, sir.
So, so here like this. what would be the layout and all. So here, as per if you use any kind of setup and all, okay, here if you are using any kind of setups and all, and then you try to see where you can reduce the cost and all. So more or less, this the current setup, whatever is given to us, that is the best setup and all. If you no matter what setup you use, you will not able to reduce your cost below this. So that we can do. We need some time and all, and you guys also, whenever you get time, you can sit and already you know the flow data and all. Costing will change, the distance will change based on the setup and all, and you can sit and calculate the distance based on different setups, and then you can multiply them to figure out does the cost has really affected or not. That calculation you can do by yourself. Fine. So here they're telling ki if you use this setup EACBFD. So E A E A, then CB, we have not written only. So if we use that setup if we use the setup EACB, and then you have left with D, right? So EACBFD. So and as for what is given in the book, that if you use this setup, your cost right now with the this setup, your cost is around your cost is around 80. So if you use this setup, then your cost will become 67. So that way, this is the good setup. Means I think this is the setup where you are getting the minimal cost. Fine. You want to calculate, you can calculate that also. These are easy numerical. You can easily do by yourself. Any doubt, anyone?
No, sir.
Then we have this illustration 13. So here they have given some hospital which have six department D1, D2, D3, D4, D5, D6. The initial layout of the hospital is given to us. Okay, and then again the same kind of question. The average traffic movement to and fro from each department is given to you. This is the average traffic flow from each department. Okay, and then the hospital want to find out the optimal layout. What would be the optimum layout for them? So this is the layout given to you. This is the layout given to us, and then we have to find the optimum layout. So again, there's no method to find this optimum and all, like how we have done in the last numerical and all. Like you have to sit and you have to draw possibilities and all. Okay, there's no formula, there's no direct way of doing it and all. Only through trial and error you can do. So that is the only way how we can do. But even then, if instead of giving these kind of question where we have to find out the optimal value, if instead of that, if they would have asked that for this layout, this is the cost, then can you suggest a new layout or whatever, if some new layout if it given, and that cost if is being asked, then it would make more sense and all. So like here you can see we got a grid with 2 into 3, two rows are there and three columns are there. Okay, so here we are assuming that this table is giving us the average number of people or traffic moving from one department to other department, and then they want to know the best arrangement or optimum layout where the department that have more traffic between them should be placed closer to reduce their total involvement and all, to reduce the cost and all. Here, how will we understand the traffic table and all? Here, you can see this data is given. For the traffic data, this data is given. Like you can see from uh, D1 to D2, if we are moving from D1 to D2, the cost is given to us is 10. And then if I'm moving from D2 to D1, the cost is given is 8. So here what we will do, so here to understand the traffic table, because like we you understand with the grid matrix, with the Manhattan distance formula, we can calculate the distance from one department to the other department, but we need to multiply the distance with some value so that we can get the cost. So as per this numerical, we'll have to calculate the traffic data or the movement cost of traveling from one department to other department. So if I consider the department D1 and D2, so the cost of traveling from department D1 to D2, it would be here 18. So from D1 to D2, it is given as 10, and then from D2 to D1, it is given as 8. So the total movement between D1 and D2, it would be 18. So like this, I'll find for each department. So here I found for D1 and D2. So like this, we'll find for each department. Okay. So if I ask you between D1 and D3, what would D1 and D3 sum? D1 and D3 sum. D1 and D3, what would be the sum? Simple. Calculate from D1 to D3. What is the cost? 20. Then from D3 to D1, what is the cost? 10. So 20 plus 10 is 30. Simple. Then from D1 to D4, it is 0. From D4 to D1, it is 0. So D1 to D4 is 0. D1 to D5 is 5. D5 to D1 is 15. 15 plus 5 is 20. Then from D1 to D6 is 6. And from D6 to D1 is 0. So D1 to D6, it would be 6. Clear, everyone?
Yes, sir.
Then D2 to D3, what would be the costing? D2 to D3.
6.
D2 to D3, it would be 6. Then D3 to D2 is D2 to D3 is 6. Correct? And then D3 to D2 is also 6. So D2 to D3, it would be 12. 6 plus 6. D2 to D3, it would be 12. Similarly, if I ask you from D2 to D4, D2 to D4 would be how much?
It is 10 plus 25.
D2 to D4 is 10, and then D4 to D2 is 25. Is it 35? Then D2 to D5 is 0. D5 to D2 is 10. That would be 10. 0 plus 10. D2 to D6 would be 2, and D6 to D2 is 6. 2 plus 6 is 8. Correct. Then D3 to D4. D3 to D4 would be 20, and D4 to D3 would be 5. 20 plus 5, 25. Then D3 to D5 would be 7.
and then D5 to D3 would be 0. 7 plus 0, 0. D3 to D6 would be 8, and D6 to D3 would be 0. 8 plus 6, 8 plus 0 is 8. Clear na? So like this we'll find the data for each department, the traffic data for each department will find. Clear everyone?
Yes, sir.
So we calculated the distance, so already we have calculated based on the Manhattan distance formula. Okay, this is the traffic data we calculated. Like we can say, like for some kind of pairs, like these all pair which have higher value, we'll say the strong linked. So if we bring closer to each other, it would be better. They are the strong link. Okay, you can arrange this data in descending order. If I arrange, so you can see this D2 to D4, and then this would be, you can see this data, these all departments should be closer to each other. Okay, if we bring them closer to each other, somehow we can reduce the cost because the traffic data is very high. Okay, then we can think about what all possibility we can create and all, where the cost can be minimal and all. So you can figure out different possibilities. Okay, so that you can either like randomly use a trial error method, or you can think about any kind of possibility. Okay, so like suppose this is the possibilities given D1, D2, D3, then we had D4. Here it was given D1, D2. This was given already. D1, D2, D3, then D6, D5, D4. So like this, we can create some kind of possibility like this. This here one arrangement is created. Are you getting this? Because we don't know what is the correct answer, what is the optimal answer, we don't know. So we have to create possibilities like this. You're getting this possibility. Now, once you got the possibility and all, so what you will do once you got the possibility, distance so it not gonna change, and distance so not gonna change, and distance will change, but the traffic data will not change. And now D3 would be 1 1. This would be how many rows? Three rows and three column. You can say 1 1, 2 1, 2 2, 3 1, 3 2, 3 3. So we can calculate the distance, and then traffic data to will not change. Okay, traffic data will be same only. Traffic data will be this traffic data would be same only whatever we have calculated, and we can just we just write down this, and we can calculate the distance, and then once we calculated the distance, we can calculate this figure value. Okay, we can calculate the figure value, whichever figure value we can calculate the coordinate based on this we distance we got, then traffic data to already we have. So if you multiply the traffic with the distance, we'll calculate the cost. We need to see which where we are getting the minimal cost, that we have to see. Okay, so which wherever you try, uh like if you try this layout and all, here you will get the minimal cost. You can try by yourself also. You are getting it right. So how to get the optimal cost, how to get the optimal layout, there's no formula. Only we have to use trial and error method. There's no other way how you can find the optimal layout and all. Once you get the layout, how will you get the cost and all? That I can tell you. Otherwise, for getting what is the optimal layout, as such, there is no formula for that. So
Sir,
if
in
you
exam, how much marks they will ask this question?
5 marks, 6 marks like that, they'll ask you. Small kind of case study they can give you. But I don't think they should ask you this kind of question about optimal layout and all, because that practically not possible. Means if I sit also for 2 hour, 3 hour also, I'm not sure will I able to get, because six departments are there. So six departments, if you arrange them, 6 factorial. 6 factorial means 720 ways. So 720 ways, so you cannot create the possibility now. Means here what you can do, because some department, uh, this data is maximum, traffic data is maximum, so we'll try to bring them together, like d2 I'll write, because d2 d4 I'll try to put them together because the cost is high. Then d2 d4, from d4 anything is connected, yeah. So from d4 d5 I can do, from d4 d5 I can do, from d5 anything is connected. Okay, no. From d5 d1 is connected, so I can bring d1 down. From d1 you have d2, from d1 you have d4 0, so I can bring from d5 I can bring d2. You are getting it now. So I can if I write, yeah, I cannot draw. So like from D2 to D4, then from D4 to D5, and then from D5 to D1. So in from D5 to D1, I can bring one arrow down from D5 to D1, and then from D1 to D1, then I have two possibility. D3, from D1, how many possibilities left? D D3 or D6. So which is cheaper? Which is cheaper, from D1 to D6? D1 to D6 is 6, and D1 to D5 is 20. Sorry, D5 से D1, and then from D1 I have two possibilities, D3 or D6. D1 and D3 is D1 and D3 D1 D3 is 30. So I'll put D3. I'll put from D1 I'll put D3, and from D3 I'll put D6. Something like this I can create a possibility. Okay, something like this I can create a possibility. And then once I got the metrics, like here there's one possibility is given. So like this, we have to create some kind of metrics and all, some kind of setup we have to create. Okay, so whichever setup, your cost would be minimal, that you need to see. Like if I see here, what I'm trying to say, like if I write D2, okay, from D2 to D4, from D2 to D4, because I'll try to bring them together, bringing them together because the cost would reduce. Objective to reduce the cost. From D4, what is the maximum? From D4 you have D5. So if I bring here D5, and then from D5, if you see from D5, one is D4, that already I have used. From D5, then you have D1. D1 is second. So what I'll do, I'll connect with the D1. Now from D1 you already D3, D1 say D3 is very high. You can see here. So I'll put here D3. And then I'm left with D6. Uh, this is one possible. What did D2 to D6? D2 to D6 is 8. Okay, fine. Then D3 say D4. it is 25. So I bring them together. Okay. So I got now this is the one layout I got. Now what I'll do, I'll calculate the distance. This would be 1 1, row 1, column 1. This would be row 1, column 2. This would be row 1, column 3. This would be row 2, column 1. This would be row 2, column 2. Then this would be row 2, column 3. Now I can calculate the distance, and then traffic data is already given here. So I'll just multiply the distance with the traffic data to find out the cost. And then the objective is to find out where I can get the minimal cost, where I can get the minimal cost, which layout, which the infinite possibilities are there. So which layout you will get the minimal cost. So if you using this layout and all, so you are getting the cost as 320. Earlier your cost was 395. Earlier your cost was 395. Now your cost has become 320. So here you got the reduction in cost. So there's no direct way of doing this. So in case if you're getting in exam, suppose if you get in exam this kind of question, so just create one or two layout and show that how your cost is getting changed. And there you can write like by using like these ways of layout, we can get infinite layout possibilities, and in each layout possibilities the cost uh, can be lesser or more, and you can give some reason of what would be the logic of this layout and all, and then you can end the question. Your question would be open ended question, means you cannot complete the question. You can give some kind of layout and all. You can give some kind of layout. You can create some kind of layout and give some kind of reason like this. Give some kind of reason why I have created this layout and give reason for that. And then you calculate the cost. Imagine your cost was before 370. Now your cost has become 320. You can give the thing that yeah, my cost has reduced and all. So like this there would be more layout possibilities and all. That way we can create layout, and that way we can reduce the cost, and you can give the reason for your layout. What is the reason for creating that layout according to you? That logic you can give, mention in the question. I think that would be more than enough. You cannot do more than that. You cannot create 720 layouts, and there from 720 layouts uh, you cannot create like which layout is the minimal and all. That is that is impossible to be done. Clear everyone?
Yes, sir.
I know. So this is easy kind of thing. Only thing you have to just use little bit of your brain and all, and whatever you are getting, just two three cases and all, and from each case you know how to do, because this I can do in multiple ways. No, I can write it like this. I can write here D1. Here I can write here D1. Then here no, because it's not given. Now I have to create 2 into 3 matrix. I can create I can create 3 into 2 matrix. I can create anything now. I can write here D1, then D2. This can be one layout. Then D3, and then I can write here D4, then D5, and then D6. So like if I start doing like this way, then it become very difficult now. I hope you are getting it. So like this you can create thousands of more than of possibilities and all. So you cannot like mathematically calculate even how many possibilities we can do, and then under each possibility uh, how much would be the costing, and which costing is minimal and all. That is really infinite, like that is really impossible to be done. So don't bother about doing that and all. So in textbook they have given one possibility. Okay, you can create some other possibility. In here they have given like this one possibility, and then they calculated the distance. This is the second possibility. Then they calculated the distance. So so they are what they're telling. See now. There's only way of doing it is the trial and error approach. So trial and error approach, there's no mathematical way, there's no correct way. So because there's no mathematical way, there's no correct way and all. So all the ways what you will do, it would be correct only. I hope you got the answer. Clear ना?
Yes, sir.
ठीक है, we'll do this much today. A resource aggregate planning will start from tomorrow. Fine.
Okay, sir.
Okay.